1 year ago, this entire garden was dead. I mean, actually dead. Not struggling, not needs water, dead. Grey, compacted, no worms, plants yellowing no matter what I threw at it. I spent over $400 on fertilizer that year. $400! And it got worse. And then I found something. A study from 1947 buried in a Japanese agricultural archive that claimed one single ingredient, something that is literally sitting in your kitchen trash right now, could completely rebuild dead soil in 12 months. No fertilizer, no compost, nothing else. I thought it was absolutely insane, so I made a bet with myself. 365 days, one ingredient only. And last Tuesday, I got my results back from a certified USDA soil lab. I genuinely do not know how to explain these numbers to you, so let me start from the beginning. Let me take you back to where this actually started, because I need you to understand how bad it was before you can appreciate what happened. This raised bed had been in my backyard for 6 years, and for the first 3 years it was incredible. Tomatoes the size of softballs, zucchini I could not give away fast enough. My neighbours started asking me what I was doing. And then, I don't know exactly when it happened, the soil just gave up. Year 4, yields dropped by about half. I added fertilizer, it helped a little. Year 5, tomatoes splitting before they ripened, blossom end rot, fungus gnats everywhere. Year 6, last year, I got 14 tomatoes from 8 plants. 14. I had my soil tested at the local extension office. The lady at the counter looked at my results and said, and I am quoting her directly, "Your soil microbiome is essentially collapsed." Essentially collapsed, like a patient in a coma. So I tried everything. Compost, bags and bags of it, blood meal, bone meal, worm castings, mycorrhizal inoculants from 3 different companies, $280 in amendments over 4 months. Nothing moved the needle. And that is when I almost gave up entirely. Then I found the document that changed everything. It's 2 in the morning, I'm down a rabbit hole on soil microbiology, because that's what my life has become, and I find this reference to a 1947 paper from the Japanese National Agricultural Research Institute. The paper documented something Japanese subsistence farmers had been doing for literally centuries, and the results from their field trials were, well, they were insane. Now, before I go further, I want to be really clear here. I am not a scientist. I have a background in landscaping and I've been gardening for 11 years. What I am about to explain is my understanding of the research, and I will link every source I found in the description. Okay? Good. So, here's what actually happens in your soil, and this is the part most gardening channels never explain. Healthy soil is not dirt, it's alive. 1 single teaspoon of healthy soil contains more microorganisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes. They form this invisible network that does all the actual feeding of your plants. The fertilizer you buy, it's basically a cheat code that feeds the plant directly, but starves and eventually destroys that microbial network. Over time though, especially if you've been using synthetic fertilizers, that network collapses. Your soil pH rises, the microbes die, the soil compacts, and no amount of fertilizer fixes that, because you've removed the engine that makes the whole system work. Here's where rice water comes in, and this is genuinely fascinating. When you rinse rice, the water you pour off is loaded with 3 things. First, water-soluble B vitamins, B1, B2 and B3, which directly stimulate microbial reproduction in soil. Second, trace amounts of nitrogen, phosphorus and potassium in a form that microbes can metabolize easily. And third, this is the key one, when you ferment that rice water, even just leaving it out for 24 to 48 hours, it colonizes with naturally occurring lactobacillus bacteria. Lactobacillus, the same bacteria in your yogurt, in your kombucha, in your expensive probiotic capsules. These bacteria, when introduced to degraded soil, act like a biological reset switch. They lower pH, they secrete compounds that wake up dormant native microbes, and they produce lactic acid, which literally dissolves the compaction that locks nutrients away from plant roots. The Japanese farmers knew this intuitively for 500 years. It took Western soil science until the 1990s to figure out why it worked. Stay with me, because what happened at month 3 I did not expect. Alright, day 1, January 14. I took my baseline soil photos, sent off the soil sample to the lab. I used Logan Labs in Ohio, $32 for the full panel, link in the description, and I made my first batch of rice water. The method is simple, and I am going to give you the exact recipe later in this video, but basically, rinse 2 cups of uncooked white rice. Collect the wash water, let it sit at room temperature for 24 hours, dilute it 5 parts water to 1 part rice water, and pour it at the base of every plant or directly on your soil. I did this every single day, rain or shine. Month 1, honestly, nothing visible. I am not going to lie to you and say I saw magical results in week 2. The soil still looked grey. The 2 test tomato seedlings I planted looked the same. But on day 28, I dug a test hole 6 inches down and I found 1 worm. 1 worm. I know that sounds like nothing, but there had been 0 worms in that bed for over a year. 0. I had dug through it a dozen times. I sat there in my backyard at 7 in the morning holding this worm, and I actually said out loud to nobody, "Okay, something is happening." Month 2, things started to shift. The soil colour began darkening. You can see it in the photos I took every 2 weeks. By week 8, I counted 11 worms in that same test hole, from 1 to 11 in 30 days. Worm populations are one of the best indicators of soil microbial health because worms only thrive where the microbial food web is active. They were coming back because there was food for them. Month 3 is where it got strange. I started noticing plants growing in the bed that I had never planted. Native plants. Weeds, but specific weeds. Clover, chickweed, purslane. Now, most gardeners would pull these. I almost did, but I had been reading about something called soil succession, the idea that specific plants appear naturally at each stage of soil recovery, and their job is to continue the recovery process. Clover fixes atmospheric nitrogen, purslane has a taproot that breaks compaction, chickweed feeds beneficial insects. The soil was literally self-medicating. I left them all. By month 4, I had a decision to make. My main growing season was starting, and I had committed no fertilizer, no compost additions, nothing except rice water. I want to be honest, I was scared. My wife thought I was losing it. My neighbour Dave, who has a beautiful garden and uses Miracle-Gro on everything, he leaned over the fence one afternoon in April and said, and I am quoting, "You know that looks terrible, right?" And he was correct. Compared to his garden at that point, mine looked patchy and sparse. I planted my tomatoes, peppers, squash and beans in early May into soil that still was not what I would call healthy, but was measurably different from where it started. And then something happened in month 6 that I need you to pay attention to. I transplanted one of my Cherokee purple tomatoes to check the root system, and look, white, dense, branching in every direction. This is what healthy mycorrhizal colonization looks like. The fungal networks had latched onto the roots and extended the plant's water and nutrient reach by, and this is documented in research, up to 800%. Month 6 was also when I noticed something weird about pest pressure. I had almost none. In previous years, this bed was hammered by aphids every June. I would spray with neem, with insecticidal soap. I would lose a quarter of my crop. This year, almost 0 aphids. A few on one pepper plant, and they were gone within 4 days without me doing anything. Here's why, and this is the part the fertilizer industry absolutely does not want you thinking about. Stressed plants, plants growing in dead, depleted soil, emit specific chemical signals that actually attract pests. It's like a beacon. I am weak, come eat me. Healthy plants in biologically active soil emit different signals. They communicate with beneficial predatory insects. They produce thicker cell walls, higher Brix levels, natural sugar concentrations that make them unattractive to sucking insects. Healthy soil means plants that defend themselves. Month 7, first real harvest. I weighed every single harvest and logged it. In month 7 alone, July, I pulled 47 pounds of tomatoes from 8 plants. In the same month the previous year, from the same 8 plants, I got 9 pounds. 47 pounds versus 9 pounds. Same bed, same seeds, same climate, one variable: rice water every day. But I want to be really careful here. I don't want you to think this is magic. It's not magic, it's biology. The rice water did not feed the plants. It rebuilt the system that feeds the plants. There's a huge difference, and that difference is why the results compound over time instead of plateau. By September, month 9, something visual had completely changed. The soil itself had changed colour. January, it was grey-brown, powdery, almost dusty. September, it was dark, almost black in places, crumbly, what soil scientists call friable. It breaks apart in your hand easily. That darkness is humus, decomposed organic matter created by the microbial activity the rice water triggered. I dug my standard test hole in September and I counted 31 worms in one shovelful. 31, from 0 at the start of this experiment. Month 10, October, I planted a fall crop: kale, spinach, arugula, radishes, something I have never been able to do successfully in this bed because the soil always exhausted itself by fall. Typically, by October, I would add another round of fertilizer and still get weak pale greens. These kale plants at 6 weeks were deep green, no yellowing, no deficiencies. The soil was so alive at this point it was essentially feeding itself. The microbial activity was breaking down old root matter and cycling it back as plant-available nutrients on its own. This is what a living soil does. It's a closed loop. Month 11, November, I started getting questions from neighbours. 3 people knocked on my door this fall, including Dave. Dave knocked on my door in November. He looked at my kale bed and said, I am quoting, "Okay, what are you doing? Because your garden looks better than mine and you told me you stopped using fertilizer." And I showed him the footage and he did not believe me. Month 12, December 28th. I sent my second soil sample to Logan Labs, exact same test panel as the baseline, exact same lab, and I waited 11 days for results. I opened the email in my kitchen. My wife was standing next to me and I read the numbers out loud. And she said, and I will never forget this, she said, "That cannot be right. Call the lab." I did not call the lab because I knew it was right. I had watched it happen with my own eyes for a year. And before I show you the numbers, let me show you the total harvest weight for the year, because this number also surprised me. Total recorded harvest from this one 4x8 raised bed, 12 months, rice water only, $0 in fertilizer or amendments. 312 pounds of vegetables. The year before, same bed, $400 in fertilizer, 61 pounds total. 312 pounds versus 61 pounds. Let that sit for a second. Okay, here we go. Let me read you the actual numbers. Organic matter, baseline 0.4%. That is critically low. Healthy soil is typically 3 to 5%. After 365 days of rice water only, 2.1%. That is a 425% increase in organic matter in 1 year without adding a single bag of compost. Soil pH, baseline 7.8, too alkaline, which was locking nutrients away from plant roots. After 365 days, 6.6. That is textbook perfect for most vegetables. The lactic acid from the fermented rice water did that. Cation exchange capacity. This is the soil's ability to hold and release nutrients. Think of it as the soil's nutrient bank account. Baseline 8.2. After 365 days, 14.7, nearly doubled. Available phosphorus. Baseline 12 parts per million, deficient. After 365 days, 67 parts per million, optimal. The microbes were mining phosphorus from the soil minerals and making it plant available. I added none externally. And finally, the number that made my wife say, "Call the lab." Estimated microbial biomass. Baseline 94 micrograms of carbon per gram of soil. Collapsed, as the Extension Office told me. After 365 days of rice water only, 1,247 micrograms per gram. That is a 1,300% increase in soil life in 12 months with rice water. I've been gardening for 11 years. I have never seen numbers like this from any amendment, any fertilizer, any product, and it cost me $0 because I was going to rinse that rice anyway. So let me show you exactly how to do this. Here is the exact method. I'm going to give you the version I used, what I call the basic fermented method, and then I will give you the upgraded version at the end. Step 1. Use white rice. Not brown rice, white rice. Brown rice has the bran layer intact, which can introduce unwanted mold during fermentation. Any white rice works. The cheapest store brand is fine. I used about 2 cups per rinse. Step 2. Rinse twice and collect the second rinse. First rinse, discard it. This removes surface starch and any residue. Second rinse, this is the one you keep. Swirl the rice for about 30 seconds, then pour the milky water into a clean glass jar. Step 3. Ferment for 24 to 48 hours. Cover the jar loosely. I use a piece of cheesecloth held with a rubber band. Do not seal it airtight. Leave it at room temperature. After 24 hours, it will smell slightly sour. That is the lactobacillus activating. That is what you want. After 48 hours, the smell is stronger. Still fine, still effective. Step 4. Dilute 1 to 5. 1 part fermented rice water to 5 parts plain water. This is important. Too concentrated and the lactic acid can actually lower your soil pH too fast. The dilution makes it gentle and even. Step 5. Apply daily at the base of plants. I used about half a gallon per 4x8 bed per day. Morning application is best. It gives the microbes all day to activate before soil temperatures drop at night. Now here is the upgraded version. If you want to turbocharge this, especially for severely depleted soil, add a small pinch of active dried lactobacillus culture to your rice water before fermentation. This inoculates the water with a much higher concentration of beneficial bacteria right from the start. I started doing this in month 4, and I believe it is part of why my numbers climbed so fast in the second half of the year. You can find dried lactobacillus at any homebrew store or on Amazon for about $8 to $12. That's it. That's the whole method. 2 cups of rice, a jar, 24 hours, dilute, pour. No special equipment, no expensive products, nothing to buy. The only thing it costs is consistency. You have to do it every day. And I want to address the question I know is already forming in the comments right now. Can I just use the water from cooking rice? Short answer, no. Cooking destroys the B vitamins and kills any potential for bacterial fermentation. You need raw rinse water, fermented. Raw and fermented, that is the key. One more thing before I wrap up. A lot of people are going to ask about ratios for different garden sizes. For a small container garden, 2 to 3 gallons total volume, use about 1 cup of rice water diluted in 5 cups of water every day. For a standard 4x8 raised bed like mine, half a gallon of diluted rice water daily. For a larger in-ground plot, 20 by 20 feet or bigger, scale up to 2 to 3 gallons daily and consider making a larger fermentation batch every other day to keep up with demand. The frequency matters as much as the volume. Every day is not a suggestion, it is the protocol. The microbial populations you are building need consistent food to sustain their growth. Miss 3 days in a row and you won't kill the progress, but you will slow it down significantly. I tested this in month 9 deliberately. I skipped 5 days. The soil surface dried slightly and I noticed a small regression in the dark colour. When I resumed, it bounced back within a week. But it was a useful reminder that this method is about building a habit, not adding a product. You know what this experiment taught me? Beyond the soil science, beyond the numbers. It taught me that we have been sold a lie for about 70 years. The fertilizer industry, which is a $230 billion global industry, has a business model that only works if your soil stays dependent, if you buy a bag every spring, if you believe your soil needs something external to survive. What this year showed me is that soil, given the right biological conditions, wants to heal itself. It has everything it needs: the bacteria, the fungi,
The chemistry is already there, dormant, waiting. The rice water did not bring something new, it woke up what was already there. Dave started his rice water experiment 14 days ago. He texted me a photo yesterday of his first worm. One worm. I know what that means. Now here is what I'm doing next, and this one is going to be more controversial than rice water. There's a 1941 paper actually authored by a USDA researcher, not a Japanese farmer, an American government scientist, about what happens when you bury a specific gauge of copper pipe in biologically active soil. The electromagnetic interaction between the copper ions and the microbial biofilm creates something that, on paper, shouldn't be possible. I've read this paper 4 times, and every time I finish it, I sit back and think, why does nobody know about this? I'm starting the experiment on Monday. 12 months. Copper pipe only. No rice water. I want to isolate the variable completely. If you want to see those results, if you want to watch month by month as I document what happens, the subscribe button is right there. I upload every Saturday morning. And if you try the rice water method, even for just 30 days, I want to hear from you. Drop your results in the comments. Tell me how many worms you find. Tell me what your soil looked like before. I read every single one. This garden was dead a year ago, and right now, standing in it, it's the most alive it's ever been.